Hi, my name is Mike Mays, and I'm a design engineer from Linear Technology, and today I'm demonstrating the LTC2983. This is a device that directly measures the temperature of thermocouples, RTDs, thermistors, and diodes. It basically provides all of the excitation currents, measurement techniques, algorithms to directly measure these sensors. And then in the back end, it converts the output from these sensors directly to degrees C. Combined with its real ease of use, it also is extremely accurate. For example, here I have a precision calibrator that's driving negative 200 degrees C simulated RTD into our LTC2983 device. And the LTC2983 is reading very precisely within 0.03 of a degree this reading. The part is also very flexible. It includes all the coefficients for standard devices, but it also can be programmed for any type of custom sensor, whether it's a custom RTD or a custom thermocouple. This demonstration is showing an extreme case where we have a custom thermocouple we made with a barbed wire and a copper. We characterized its voltage temperature properties, and we store it in the device. It can now directly measure the temperature of this device and output the results in degrees C.
We are here to present you the latest release of LTC's backup regulator part. It's the LTC3350. The block diagram is shown here. So what the part is capable of, it regulates main power flow, just dropping the input, and the output is following the input. And with additional power, which is not needed by the output, this supercap reservoir is charged via this buck regulator with a constant current charge algorithm. And in case the input power goes away, this buck regulator gets bidirectional and works as a boost regulator, which uses the energy stored in the supercap, or battery if you like, and is then fed via the boost regulator to the output. And as you can see, it's a controller with external feds. The 3350 is capable of doing a lot of power. We're talking about 40, 50 watts of backup power, which was not possible with the parts anyone had before, which are integrated. And you see this slide diagram here. The normal application, the red one, is the input voltage. It goes away, and the output stays constant and stable because the energy of the cap is discharged with the boost regulator. And what we have here on our showcase, that we have just two light bulbs as indicator for the input voltage. The second light bulb indicates the output voltage. And when I now switch off the input net, the supercaps have been charged by the PCB with the 3350 on it. You see that the light is still running. It's not so bright as before because we have chosen 6 volt as a hold-up voltage, but this can be adjusted digital by the part itself or manually with feedback resistors. That means we can go shortly to the software, which is possible with this part as it has an I2C interface. That means we go to the configuration and we would choose the backup voltage and store this value to the part. And when we go back to the graphical show up, don't get annoyed by the spikes. It's the software's prototype status. And I go back to the light bulbs. Now we should see that the light bulb, the output voltage, stays the same brightness as we have 12 volt over here. That means the green one was the input voltage going down. The blue one is the output voltage that stays constant, and the red one indicates the voltage on the supercap reservoir, which is discharged slowly by the light bulb. And when it's done finally, it cannot hold longer, the supercaps are discharged, the part shuts off completely. And with this part we have a lot of additional feature because it offers a balancing of the supercaps. We offer a kind of health monitoring because the part can measure the capacitance of the supercaps as well as the ESR. So the user has always the control of the health status of the energy reservoir and can see if it's necessary to exchange them or that everything is running fine with this application. And with this part, I think we have a really capable solution to offer backup power, which is really higher to supply system loads, which are talking about 30 to 50 watts, for example.
So this is the show of our power system management solutions that including a 4-channel PM bus power system manager where you can get accurate input current and energy measurement as well. You can sequence, you can trim, you can margin your power supply on your devices. The LTC 2975 is a 4-channel device and you can drive 4 different power supply devices. And the LTM 4675 is a micro module dual 13 amps that you can parallel up to 26 amps as a micro module regulator. And on this device there's on board the PM bus power supply system management. And you can manage all the output voltage level, you can manage your current protection, you can manage sequencing, you can manage the switching frequency on the device, and you are interfaced with the E2C and PM bus. This device and this demo is a fully demo where we include a battery charger that is driven by a hand crank just to provide a real accurate measurement of the energy that we are producing. For example, we can read the energy produced in 20 seconds, and we can read the power that is produced by 4 LED drivers that are on the main board. And in the meanwhile, we can control and read all the power that is used by our micro module evaluation board, where we can provide up to 120 amps on 1 volt output. That is a really powerful solution, and you can manage everything by a PM bus, and you can have under your control all the status of your power system. So you can read voltage, current, energy, power, temperature, and you can read it by a graphic user interface that is really easy to use, where you have under control on over your devices that is inside your system. You can manage by this graphic user interface the sequencing, you can manage margining, you can shut down and turn on your system with different sequencing and different timing, and you can manage everything on your system related to the power supply. And now we have a customer that is trying to use the device to charge our battery and to let us know. Please wait your start sign. Go. Please let the light get more blue or maybe green.
Green is better than blinks.
Hey, come on.
Okay, so you produce 88 joule, and now let's see another customer. Ready to go? Let's wait to finish the publishing. Okay. In the meanwhile, you can see that we have the LED blinking. This customer is really powerful.